Looks like someone's hungry. We've always known that human breast milk is best for babies. It's purpose-designed to provide balanced nutrition when it matters. That's a fact. It's also a fact that for many reasons more and more babies are being fed on infant formula. Responsible manufacturers do their utmost to mimic the components of human milk as closely as possible. But this is no easy task. Human milk fat is highly complex. And while it is possible to imitate its fatty acid profile fairly accurately by blending vegetable fats, imitating its structure is much more difficult. But why should this matter? To answer this question, we need to explore how milk is digested in the human gut.
Well, we've known for a long time that human milk fat is better absorbed by the baby than vegetable milk fat is, and there have been a number of ideas as to why that should be so. We are beginning to appreciate more and more that the structure of the fats themselves plays an important part.
This is a model of the triglyceride molecule found in human milk fat. Attached to the glycerol backbone in position 2 is a large proportion of palmitic acid. This saturated fat is one of the most abundant and nutritionally valuable components of human milk. The outer positions, 1 and 3, are occupied by unsaturated oleic acid. When the milk passes into the intestine and the digestive enzymes get to work, they split off the acids in the outer 1 and 3 positions, but leave the palmitic acid, now a monoglyceride, to be easily absorbed through the gut wall. Now let's compare this with the triglyceride found in a typical infant formula based on vegetable fats. Although the fatty acid profile is similar to human milk, the position is structurally reversed, with most of the important palmitic acid attached to one or both outer positions. In the gut, these get split off first by the digestive enzymes and become free fatty acids. In this form, the palmitic acid can then bind with calcium, making insoluble soaps. These can't be absorbed and pass straight through to the large intestine. So what effect can this have on digestion and nutrition?
Well, one is that if palmitate is in the 1 and 3 position, then it will be less well absorbed, so we have less fat absorption, particularly of saturated fat. You know that we're all supposed to be reducing the amount of fat in our diet as adults, but in babies, fat is a very important part of the diet. Something like 50% of the energy in breast milk is fat. And now this is really quite important from a clinical point of view. One of the great difficulties in premature babies is achieving adequate nutrient absorption, particularly with calcium, where they have very rapidly growing bones, and we need to put a very large amount of calcium into them very rapidly for them to grow and develop at the same rate that they would have done inside the mother's womb. And then the presence of calcium soaps in the intestine can affect the biology of the intestine. So we've been very interested in looking at this whole area. We did a study with Colworth some while ago to look at the idea that maybe calcium soaps forming in the intestine of formula-fed babies could account for their greatly increased incidence of constipation compared with breastfed babies, and we found that this was the case.
While these fundamental problems with vegetable fats have been recognized for some time, until recently it was impossible to do much about them. Now, however, thanks to a breakthrough in fat processing technology, there is a solution.
The principle of this new technology is to rearrange the fatty acids on the triglyceride with great accuracy. And this technology is much more precise than chemical interesterification ever could be. This technology was originally developed for use with confectionery fats. However, my colleague Fred Padley realized that there may be wider applications, for example, in infant formula.
When we had the first ideas on human milk fat, we were just trying to copy the fat in the same way that we'd copied cocoa butter. We'd not been in nutrition before, and in that sense it was a very new experience for us. So under Alan Lucas's guidance and then Paul Quinlan's involvement, we were able to develop our ideas on nutrition and to demonstrate the benefits of this unique structure in the fat.
While enzymic technology makes it possible to engineer fats very precisely, it requires equally precise process control. This fat modification facility is the most advanced of its kind in Europe, and it was here that the new technology was put into full-scale production. But how exactly is the fat structure modified? This is the human milk triglyceride that we have to match, with its fatty acids attached in the familiar oleic-palmitic-oleic sequence. The new process starts with a vegetable fat triglyceride which has palmitic acid attached in all three positions. In a similar way to the human digestive system, the enzyme technology splits off the palmitic acid from the outer 1 and 3 positions. This leaves a single palmitic acid still attached to position 2. Oleic acids then attach themselves to the vacant positions. In this way, a precise match with the human milk fat triglyceride is achieved. After further processing, the modified triglycerides can be simply blended with other fats to provide infant formulas that are both chemically and structurally similar to human breast milk. This new infant formula fat is called Betapol. But what difference does it make in practice?
We've now been doing some collaborative research with Unilever to look at the consequence of adding those special structurally engineered fats into infant formula. Now, the last study that we did was in premature babies. We did this in Liverpool, and we decided to test the hypothesis that if we put structurally engineered fats with palmitate in the 2 position, Betapol, as it's called, into a preterm infant formula, we would improve fat absorption and calcium absorption in those babies. And we have done just that. Fat absorption, particularly absorption of palmitic acid, and calcium absorption are greatly improved by adding this product to the formula. So I think here there is a potential advance in the treatment or the manufacture of formulas for premature babies as a result of this product.
Betapol helps to overcome many of the nutritional and digestive problems associated with traditional infant formula fats. Thanks to this new technology, formula manufacturers now have the opportunity to take a step closer to the ideal of human breast milk, helping to ensure that the ultimate consumer stays happier and healthier.